Okay, so we start guys now. So hello everybody, and for tonight we do a walkthrough on how to solve this solve this challenge rampage.exe executable. So this challenge is personally made by me. So I will walk through on how to solve it and what technique that I use to solve this question. Alright, so two tools that I will be using is Ghidra and X32 debugger. So make sure you have this, and if you do not have, maybe after this video you can download and try this on your own. Okay. Alright, so we are ready. So let's analyze this. So one things that I usually do before analyzing any executable is to check the characteristic of this executable. So usually I will use these tools, exe info pe, or let me just copy it here. Alright, so I will use these tools to know the characteristic of this executable. So let me drag it here, and it said that this image is 32 bits executable, and it was compiled by Microsoft Visual C++ compiler. Alright, so because it is 32 bit, so we need to use 32 bit debugger. Alright. Okay, so after we have known the characteristic, so next thing that I usually do is to analyze the binary. So to analyze it, you have two choices: either use debugger or you use the compiler. So there are varieties of tools out there, but the one that I will be using in this tutorial is this two, Ghidra and X32 debugger. Alright, so first thing that I will do is open up this debugger, this decompiler, sorry, Ghidra decompiler, and let's analyze this binary first to know what it does, what it expects from us. And next, make sure that you use virtual machine, right? So you don't want to run any unknown malicious executable inside your real machine. It will create havoc for sure. So make sure that you create your own virtual machine. It doesn't matter Windows 7, Windows 8, Windows 10, it doesn't matter. But at least you have an environment that can protect you from all these, malicious software or any unexpected behavior that any program might create. Okay, so we have opened this up using Ghidra. So let's analyze this. Yes. Hi. Alright, so we have Hongwei and Trailblazer here. We have the winner. We have the solver actually. So congratulations to these two guys. We have Hongwei and Trailblazer. So I will try to solve this using my own way. And if I don't think my way is actually different from these two guys, but then for others maybe you guys can learn a little bit more. Alright, so I have opened this using debugger, and next I will look into the main function. So let's try to find main function here. It doesn't show any function which name main, so maybe I try to open the entry here. So this is the entry, the real entry point of the executable. And the tip is that for Microsoft C++ compiler, for their entry, you need to look up at the bottom, and you will usually the main function will be here, because as you can see from two instruction here, we have p-argv and p-argc. So if you have done any C programming, you should know this as a parameter to the main function. So I think this is the main function. So let's open this up, and yeah, so I think this is the correct one. So we have the banner here, and we have uh printf function here, and we have for fgets here, and we have a lot of things lah. So maybe I should try to rename this first, so we can have our way easier to find like the main function later. Kitchen me. Oh wait, that's oh, I see, I opened up the wrong binary, sorry. So this is not the one, so I will close this up, sorry. Okay, sorry. But okay, I will restart the analysis again. But we know that this is a 32-bit executable. So thanks for Naja for pointing that out. Alright, so let me open up the right one. Okay, think it took some time to open this up. Oh, okay. So rampage has not been analyzed. Would you like to analyze it now? Yes, analyze it. So this is the correct one. This is not the different one. Oh yeah, Trailblazer. I opened up the wrong software, the wrong challenge. So sorry. So this is the correct one. So let me take a look into this. Let's wait until the analysis has completed. Okay. All right. So the analysis has finished. So let me find the main function. It should start with main. Where is m? So there is no main function. Let me try to check this. This is not the correct one. Okay, if you have trouble in finding the main function, so use the trick that I mentioned before. So look into entry function. This is the real entry point produced by Microsoft C++ compiler. So you look up until the end of it. So I think this is the one. So because from previous analysis we have p argv p argc here, but it doesn't show here. So let me just put a comment, or let me just look into this function. Is this the correct one? I think this is the correct one because we have a string here, current id. Yes, so this is the correct main function. So we just rename it to main so we can find it later if you want to. Okay, and then we need to fix this parameter. So what I'm going to do is that I'm going to edit function signature and provide the real parameters of the main function. So the return must be integer. All right. Okay, so we have fixed that, and then the second parameter for main function is argc. So the data type is int and the name is argc. So argc standpoint how many argument is provided to the program. Okay, and then the next one will be argv. So argv is a char pointer. So char pointer to the pointer, and we have argv here. Yes, I think this is correct. Call fix up. I think this is just fine already, so I will just click OK. Right. Alright, okay, so we have a variable here and we have a fopen function. So let's look what this fopen what is the parameter of this fopen function. So let's look at this. So we have buff here. I'm not sure why Didra doesn't automatically populate this string into this one, but I guess maybe we can try to fix this up. Retard global. Maybe we can try to fix this using this. No? Wait. I haven't done this thing, so I need to try an error. No. Retard global. I'm not sure to actually fix this up. Maybe I just skip this and just make a comment here. So this is wait, undo. So let me undo that and see again. So we have buff here. So the first parameter is buff. So fopen buff, and buff. I'm not sure about the second argument. Let me look at it online. Fopen, and the next parameter is mod. So let me look at it again, and we have rb here. So here is the correct one. So it might be this. Okay, alright, so here is the handle to the file. So it check if the file is not empty. It means that if somehow fopen fails, then it check for this. And second, it do a f6 and fstel and f6. So if you see these three combination of code, this is usually usually an instruction to find the size of the file. So let me just put a comment here. Find length of file bytes. Okay, because what it does is that it will seek to the file, to the end of the file, and it will call the ftel to tell the current position in our file, which is the end of the file. So we have here max count, and it will reset the pointer again to the beginning of the file. So that's why this string instruction is instruction to find the length of file. And then we have a function here. I'm not sure about it. Let's look at the parameter. We have a and 0. Never mind, I will skip this and we come to this later. And we have a Windows API function here, which is get process current ID. So it will find the current process ID of the current process that is running. So and then we have the same function, and let's take a look at this. And this is a string, so the string is this. Yeah, I will just put a comment on the right side of it. So it will be not sure. This is a function, not sure. I'm not sure yet what this function does, but I think this is a high probability of a printf function because we have a format string here. And yeah, I think that is it. I think this is a high probability that this is a printf function. So I will just put a comment here. If we made a incorrect assumption, then we can just rename it later. So this is printf. So this is also a printf. Yeah, so that's correct. Okay, so if you look closely, you will notice an anomaly here. So current PID, and it expect to accept one decimal, but there is no parameter here. So I think this is Ghidra fault, because if you look at the assembly here, before the call to the printf, we can see there is a to push here. So this to push is the parameter of the printf call. So here is the second parameter, and this is the second this is the first parameter, sorry, and this is the second parameter. So second parameter from get from eax, and eax is the return value of this call. So let me rephrase again. So first we have a get current process ID, which will return the current process ID into eax, and printf we print the current ID into the console. Okay, so we have done here. So let's take a look into this. So we have a fget function here. So fget is a function to get a input from stream. So in this case, we have three parameters here. Here is the destination, as you can see here, buffer, which is destination. This is the current maximum size that this buffer can hold, and this is where we want to get our data from, which is from this file. So local 10 will be let me rename this, will be data from buff. Alright, okay, and we have a uvar1 here. So looking at it, because we have a uvar1 and we have it inside this loop, so I probably think this is an index. Alright, so let me rename this into index or idx. It's just same, right? and then we have this inside the do while also. But the thing is, this, unlike this variable which is reference inside the buffer, this doesn't get reference anywhere inside the array. So let us skip this for a bit, and let's look into this. So if max count is 0, it's not 0 if, or we can rephrase it into, if far buff is not empty, and then we have a do while here. So data from buff, which we have the index here, is starting from 0, and data from buff XOR with this constant. So we know that for every for every byte in buff, it will be XORed with CC, right? And then we have a index increment here, and what is this? Because this variable doesn't use everywhere except for the initialization and inside this, on this loop. I think we can just ignore this one. Ignore. Oh, sorry. Okay, all right. Then okay, and then so what is the problem with this program? So uh if you look into the challenge description, it asks you to pop a shell. So when it asks something for pop a shell, or to overflow, or to corrupt the stack, it means that you need to do a buffer overflow. Okay, so let's analyze this. We have data from buff here, and it will be read using fget. All right, and then every bytes in that has been read will be XORed with this constant. All right, so the vulnerability is here because uh, because it doesn't check the length of the buffer, it just check the length of the file. So this doesn't look correct, because if your file contain data up beyond what the size of this buffer, this area offer, then we will have an overflow. All right, okay, so let's try this. So I will run this program. Okay, and let's run this. So it need a buffer function. So let me open up a text editor and just fill up a random data here. Oh shit, do not ask this question again. Okay, alright, so let's save into this folder. Where is live folder? Here, and let me rename it into buff. Okay, so we have buff here, so let's try it again. Let's try to run this again. Rampage. So it works, right? It doesn't have any error or anything. So let us try to increase this buffer size. Let's just put a lot, so we can really be sure that this is buffer overflow. Alright, so this buffer look large, so let me rerun this again, and we have seen that the program stuck. So this is a good indicator that this program has buffer overflow. Alright, so we need to do something now. We need to exploit this file. Okay, so when we want to exploit something like buffer overflow, we need to check for its protection. Alright, okay, so the most common one is DEP, which stand for data, I'm not sure, but data executable prevention, if I'm not sure. And another one is ASLR, which means that the address is different. The address is different between each when you restart your OS. Okay, the address of the module will be different. every time you restart the OS. So it will make the overflow to be difficult. But then let's just try to solve this. Okay, so let me open up debugger here. So I use X32 debugger. This is a very good debugger. And let me just increase the font so you can look clearer. You can see clearer. So let me just put 16 for every of this. Okay, done. So let's try to run this file under the debugger. Oh, I need to open this because this debugger is elevated. And so this is the file. Okay, so let's rerun this. As you can see, we have an exception here on A, which means which the exception is exception access violation. So this exception means that your program is currently trying to reach an unknown address or address that is protected. Okay, so the address is A. So as you can see here from our data, and here you can see that the return the some address has been corrupted, and the program tried to go into this address, but this address currently doesn't exist, so the program crashed. The OS crashes this program. So alright, so let's try to rerun this again, and let's find the main function. Okay, so from Ghidra we know that the main function is here. So the main function is here. So first I want to actually take a look at the protection. Oh wait, so if you want to check for protection, the binary protection using X64 debug, you can actually use this plugin made by our Malaysian friend Marcus, checksec X64 debugs. This is a very good plugin, I use it a lot. Alright, so let me just put it into my debugger. So right, so we have 32-bit and 64-bit. Let me just copy this two and put it into the right folder. So this is for 32-bit and plugin folder, and I will just paste it here. So I will take the next one, 64-bit, into the another folder, plugin here. Okay, so let me close up my debugger and reopen it up again to reload the plugin. Okay, so let me rerun this again, and oh sorry, I need to open this up like this. And if you go to the plugin, we can see we have a checksec plugin here. So if press check, it will show the protection of all the modules inside the process. So as you can see here, we have 4 modules. These are the main modules, rampage.exe, and we have 3 additional modules, which is the library. Library where this tree is library. So library that provides function to this main module. Okay, as you can see here, for these 3 modules, these 3 Windows module, we have DEP, yes, ASLR, yes, GS stand for gut stack, if I'm not mistaken. You can just Google it and learn about it. And we have CFG, we stand for call, I'm not remember which, wait, let me Google it. I'm not quite remember what is CSG. CSG stand for control flow gut. Okay, and lastly we have if this binary is signed. And as you can see, our main modules, all the protection except for safe SEH has been disabled. So because DEP is disabled, ASLR disabled, all the protection is disabled, so we will have a very good time dealing and exploiting this program. Okay, so we know that the protection of this executable is not good, so we can have our good time exploiting this. So back to our main topic, to find the main function inside this as debugger. So my trick is usually to open up the compiler and take the address here. So we have the address here, and remember, because our program, the ASLR is not enabled, so the address will be static every time, so you don't have to worry about protection in this challenge. So I will press Ctrl G and paste the address here and go to the main function here. So I will rename this as main function, main. Okay, alright. So this is the assembly of the program. So let us try to run this until the the main function. Oh wait, sorry, let me rerun this again. Wait, why it doesn't stop at main? Maybe I didn't set up the breakpoint. I forgot to set up breakpoint. So we just press the little circle over here to set up the breakpoint and rerun this again. Okay, so our execution is stopped in the main function. So let's try to run this step by step. So let's monitor this on the right side, and we have a debugger on the left side. So let's rerun this. Run. Until we can see that you find the fget function. Run. So this is printf, because it is printing something to the console. So this is printf. So let me rename this. How to rename this label? Here. So this is printf. Okay, and this is get current process. Okay, so the API is here. There is a printf. So looking at the compiler, we can see that after all the printf, we have a fgets here. So we can show that this is a fget function. So let's rename this labels and label this this destination as fgets. Okay, so this is the parameter to the fget, and here is the call to the fget itself. So if you try to call fget, wait, what is this? Oh, so after the fget, we see that our program crashes. Okay, so we need to put a breakpoint before the fget is called. So the fget is here, so we need to put a breakpoint before the instruction is run. Okay, and then we need to monitor our stack here. So let's look for buffer overflow sign. Wait, it doesn't show anything here. Let me just increase the buffer size. I see, because this data has been sorted with this constant. So this is actually the data that has been sorted, but I'm not sure yet. Just let me rerun this until this point, and let's try to step over one time. Actually, it crashes inside this. Okay, let me just reduce the amount of buffer here, because it is weird that when fget reads something and then it crashes. Okay, usually the crash will happen at this after the return function, but then let's try. So f here, and our buffer is quite big, but then it's okay. It still crashes, so let me just reduce the buffer again. Yeah. Hmm. I'm not sure, but never mind. Let me create a Python script to actually output the bytes that I want zeroed with this constant here. So let me create a quick Python file. So we have notepad plus plus here. Whoops, this is all the secret. Close all but this. No, 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 no. Okay. I guess you guys can just pause the video then to know the real content, but then you don't mind, right? So the owner of this computer doesn't mind about the data. Okay, so let me do a quick Python scripting here. Python. Okay, so we have buff. So let me just put it like this. So this is our buffer, and the buffer will be then zeroed with 0x60. So for C in buff, then let me create a new list here, buff zeroed, and then buff zeroed, how I'm not wait push C uh, ord wait ordc to get the ASCII of this character and zero it with 0c 0xcc. Okay, so let's print the value. Test.py, and where is my command prompt? This one. Okay, so build and test. Oops, how to push using Python? I haven't done Python for quite a while, so Python is push. Oh, append. Alright, so the correct syntax is append. Alright, so let me rerun this again and see the value there. So this should be the value after it has been sorted with 0x60. Okay. Mm, Alright, never mind. Oh, let me print it in hexadecimal so we can look better. So print RDC. Oops. And hex. Yeah. So this one doesn't need it. And let me rerun this again. So we will have 8D if the so 8D is the data that is in the stack buffer after we have the buffer operand. Okay, now let me take a look at this again. Okay, let me and run. Let me reduce this. We have until, let's just overflow some byte, not all the way into the fget internals. Okay, so let me save it and rerun this again. Okay, so it works right, but then if you can see here, oh, I think I know what is the problem. So it doesn't show the correct value in the stack because it the program crashes inside the fget and the code doesn't go into here. So here is the routine to decipher the bytes back into the original data. So let me just put breakpoint here. Okay, so I can skip all of this jump. So skip all of this directly into this. So if our buffer overflow is correct, this value will be overwritten. If I'm not mistaken, yeah. So Let me just increase this one again and run this and rerun this. As you can see, we have an overflow here. Okay, so congratulations if you have reached this until this point. Okay, so let's continue. So we want to override this value with something else, with some other address that we want. Okay, so another trick that people use when searching for this for the what offset that you need to modify is to use a pattern searcher. So buffer overflow pattern generator. So using a pattern is much nicer because you can spot which where you need to edit and put the data. So the light is 200 and here will be our data. Alright. Oh wait, why I still edit this file? I will just directly edit here. So here's our pattern and let's run it. Okay. Oh wait, after I have sort this data, I need to save it into a file. So with open buff write bytes. No, this is not byte, but maybe I can just convert into a byte as f out and f outright. But sorry, join char c to convert every bytes into this buff into convert every byte into a character, and for c in buff 0. Okay, so let me try to run this file. Oh, a byte light is object required, not htl. So but okay, so I need to put here include to convert this into into a bytes. Okay. Oh shit, I open up the correct program. Let me close it up and let me validate this. This object has no attribute include or because damn, this is where should I put it? I should put it at the end of here. Okay, so the script correct. Oops, shit, sorry, I opened up the wrong page. This guy sure has so many tabs. Okay, so I want to actually minimize to resize this. So let's look at the buff hxd and buff here. So we have all the data here until 200. We have wait wait, let me check the other file. I'm not sure about this actually. So this is the old file and we have a few new file here, so we can safely delete this and we can try to rerun this binary again. So let's just run it until the read. Oh, okay, so something crashes. Maybe I should reduce this pattern here, because from previous experiment, if the buffer is too large, the program crashes before the return function crashes inside the app get. That is not what we want. Okay, let me just put it like 40 here. Alright, so rerun this Python file script and rerun this program again. Okay, so we do not have problems, and relation to this, I'm not sure whether this is overflow function on overflow data or not. So let me look into the dump and just go to hex.exe. Wait, I don't think this is the I I don't think this is the buffer. Let me recheck again. Maybe we should increase the pattern size. 40 and 60. The thing is, we want to increase the buffer size, but we do not want to make it crash inside the get function. Maybe you guys can come up with a better way. So this is my own way of solving things. So let me rerun this again and rerun this debugger again. I'm wait. Do our buffer is correct? Oh, it's correct. Wait, let me preview in the dump. Let me increase the size again. This is quite weird actually. And let me, oh no, the 100 will be enough. So let's try this and run this to create the buffer and rerun this. Wait, run. Still doesn't work. If you just put it 150 here. Wait, I'm not sure what this error means, but then it error because wait, ESI equal to this, move back pointer from AL to this doesn't make sense much. So let me reduce this. Maybe there is a mistake. Maybe I made a mistake, but let me just retry this. Let me recheck this for C in buffer sort. Print and here we have 0D and we have this one. Sorry guys, I'm stuck a little bit here. Oops, I made a mistake here. I don't think I need to make this. Let me run this. Let me check it with my file. Wait, why I have this C2 here? I think my script is in produce an incorrect buffer, so uh, hmm, wait. Let me just put it into byte array. I'm not sure. Wait. Oh, I can just put it like this and buffer repeat this chr like this, and then we convert into bytes. Yeah. Oh wait, I do not want to delete this, so let's check. Wait, string argument without encoding. Where do I make mistake? Let me just move this. Cannot conquer, or maybe I just need to input this. Wait. Why? Oh, okay. I can, because this has already has the buffer invite, so we can just directly write that there, and let's take a look again. Hmm, do you guys know what this C2 means? Because here it doesn't have C2, but then in the output it have C2 here. What is this? Or maybe I do not need to use bytes and just use the normal, you know, UTF-8 formatting. This will make our life more a little bit more easier, I think. And this, no, wait, just, wait. This is really weird. This is very weird. Hmm. Or I can just make like this and pen. Sorry guys, it has been a long time since I do a Python scripting, and I forget most of the concept already. Okay, maybe you can just do this. Yeah. This object has no attribute. A pen. I have a double P here. Uh, no, maybe I can just click bytes here, and yeah. Okay, so alright, so we have fixed the script problem, and now let's rerun this, you know, under debugger. Okay, so now we got the correct value here. So following down, you can see here, this is the value. Okay, so here is our buffer, and our buffer just overflowed the return value here. Okay, so we need to somehow replace it with with another address, so we can run our we can do arbitrary execution. Okay, so we need to search it inside our pattern, so I will just copy this, copy, wait, here. And remember that guys, this is in the related endian format. Okay, so you need to reverse the order, a5a, and search it into here. Where is it? So okay, so we have found it. So here is what we need to replace. We have, sorry, let me search again. I want to mesh cases, and no, I wait, why it doesn't found. Oh, okay, so here the debugger has already converted this into its correct order. So here will be our IP, and you can just remove all of this. So here is the padding. and here is the value that we need to value that we want to override. Okay, alright, so from this description we want to pop a calculator, right? So in buffer overflow, when you want to when you want to run something, you need to create your own shellcode. Okay, so shellcode is defined as a small set of instruction that run in a particular architecture. For, let's say, we have a shellcode for 32-bit system, Intel's 32-bit system. We have shellcode for Intel 64-bit platform, and we have, shellcode for ARM platform architecture, and those are different, right? So those are different. Okay, so the shellcode that you need to craft depends on the architecture that you are targeting. In this case, we are targeting Intel 32-bit program, so we need to find shellcode for this architecture. So let me find it. Shellcode X, etc, and we will attack Windows and calculator if somebody have already done it. Okay, so we have found somebody who have donated this shellcode into the GitHub. So I think I will just copy this to save time. But then the general idea is that, let me create a editor here. So we have buffer here, buffer we X as a padding, and we have address that we need to override. So the general idea is that you want to jump into the address that you can control. Okay, so the most basic trick that people use, that you jump into the stack and then you put your shellcode into the stack and run the code from there. So this address, you need to jump into location where we can get arbitrary execution. But so the easiest target will be stack memory. But then attacking the stack memory has a caveat. So the caveat is that if DEP is enabled, then you cannot run code inside stack. Some modern OS also included an RSLR. So what it does, that it will randomize all module based address. So when it randomizes the module based address, so you cannot use trick like ROP, return oriented programming, to bypass the DEP. So DEP and ASLR, these two protection is usually used in all OS to protect program from getting arbitrary execution, whereby if the program has buffer overflow. Okay, so we do not have to any of this, so this will be easy. Okay, so the another trick that people use to jump to stack is that you find an instruction that has this pattern. So jump ESP. So ESP contains stack pointer, highest contain lowest stack pointer, or current stack pointer. Okay, so the illustration will be like this. So we have our stack here. So we have data here. So this is our data area, and we have return address here. Return address. Okay, so let's say that our buffer, where the fgap we write into, will be here. Here will be our buffer. Okay, and when we do overflow, it will override all these until this. Alright, so you want this to jump into this. Alright, so let's find this instruction inside the binary. So I will use search for current module. We want to find inside the rampage.exe module because it doesn't have dep, and find for module, right? So you just put the instruction there and you find, oh, it doesn't find any. I'm not sure if my instruction is correct, but then current module, let me search for pattern. So let me just google out what is the opcode for jump exp. Hmm. Or you can use call exp. I'm not sure call exp will be correct. Then X assembler. So I want to find jump exp. So assemble this and get the opcode and use the pattern searcher to search for this opcode. Search on this module. Can I say something? Find pattern here. So my pattern will be this one. So let's search it and we found something. Wait, I'm not sure if this from this side, from this area. Wait. Or maybe you can search for calc.exe. Let's try to find for this. Find pattern and this one. So both of our call exp and jump exp doesn't exist inside this process, inside this executable. So we need to find somewhere else place that you know that we could jump off to. Never mind. I think I will just use the addresses here inside the modules. So wait, let me find again. So we have jump exp. Wait, because our stack is not randomized, we can just jump into the stack, right? So go to memory dump and follow in memory map. But then you can see we do not have E flag here, so means that we cannot wait. That is quite weird. Let me check this again. It doesn't have DEP, right? Wait, let's maybe run this. Go into on the search for this and go to this Windows 7, right? Yes. Wait, let me just root this. Of course that this will crash. Okay, uh, here I try to jump into this. Wait, but then stack is not executable, so that's what's concern me here. Supposedly we will have a if flag here, means that the stack is executable, but then it doesn't have any of it. It's weird because from my testing from my laptop, it has the flag. Let me just experimenting with something. I will get this address here and let me jump into the address. Let's see. So import struct. So we need to convert our value here into little Indian. So I will use struct.pack and Google up for the documentation of struct pack. Oh, pack into little Indian. So we have here for little Indian, and we need to find integer. So I will just put I here, or maybe I use I for unsigned integer, and then let's try to execute my example payload. Wait. Oh god, wait. Maybe I just put the B here. For C. Okay. Expected by INT found. Oh my god, wait. Wait. Maybe I just remove the ORD here. Just run this and rerun this back. Oh, looks like the offset is incorrect. I just add another one. And rerun this code again. And that's good. It doesn't jump. 6.1. Where is 6.1? Why it doesn't follow up this value? So EV. Oh, I see. I think I get it. 40. Wait. I opened up the wrong program, so let me run this again and run the debugger again. Or maybe I need to remove to fix the offset here and run this again. This is weird actually. Wait. The last part is. Oops. Python script, yeah. Just add another buffer at the end. This one right? This one right? Okay.
No. This address, you add another buffer.
Oh, that is the way, eh? Okay, let's try that. So our padding originally, what is the original padding? Oh, here is the original padding. So Naja advised me to add one more small buffer at the end of it. So let's try. Oh, I need to run this one script. Run this. Okay, so thanks for the assistant. So as you can see, it jumps to the this experimental correct address. So okay, so we now know that our buffer overflow is working. So here we need to jump exp, but the problem is the jump is exp instruction doesn't exist inside this rampage.exe. So maybe we can rely on another you know relies on another for now we can rely on another modules to get our rob gadget to get our jump exp. Maybe you can use another trick that can survive between different reward and can still works. Okay, so I will find jump exp. Oops, wait, where is my assembler? Online assembler. Also jump exp, and want to get the opcode. So here is the opcode. So find this inside debugger and search for current mode. So sorry, go to memory map and search for pattern here. So we want to search for jump exp, here the opcode, and we find some. So let's copy this. You just remember that this module might have ASLR, so this address might change. So I'm using this trick because it is the fastest way to demonstrate buffer overflow. Okay, if you want to try to customize a bit and do not try to depend on any jump exp from all these modules, because all of this has ASLR enable. Maybe your code will exploit here, but if you try to reboot your system, it will not work because the address has been changed. But then for quick demonstration, I will just use this address here. So ASP will be on this address, and then we need to place our shellcode here. So never mind, let me try to run this first to know where the stack will be located after the overflow. So we jump to jump exp and we jump through 0cc here. So we jump to this one. Okay, so because we have, and wait, cc will be the end of this, so it will be, let me experiment with something. Try to put a b here. Let's see the effect. So we jump to exp, and here as you can see we have cc61. So wait, go to dump. So we need to place the shellcode here. Shellcode here. Okay, this is unused, but this is important. I'm not sure. Maybe I need to investigate this more. Why we need to have written to stack? The stack. This is written. Yeah, you put the shellcode inside the stack, and we run it from there. Okay. No. Okay, alright. Sorry for the interruption there. So let me finish this one. So the shellcode is here. I already tested it before and it works. So and the plus it pop up the Azure calculator. So we want this. So open. We want to download the binary file, and I can use this one here. So here will be the code, the shell code. Do you have it? You have to get, that would be nice. So alright, so we want to read the shellcode from the file. So read open here as read bytes and as file in read plus, and our buffer we call it. So shellcode will be here. Okay, so let's try to run this. Oops, sorry. And let's try to rerun the program again with our modified path data. So here we will jump to exp, and yeah, so we got into the stack area. Follow in map. The thing that bugs me in the X64 debugger, it doesn't show the executable flag here. I'm not sure because we can execute stuff from this area, but then this debugger doesn't show the executable flag. I'm not sure, maybe it's my fault, maybe the debugger fault then, but then our shellcode is working here. So we can just jump the run this until this, and tada, we have our calculator here. After 1 hour, finally we got the calculator. Alright, so okay. Alright, so this is the code. You know, I will put this into the comment. Okay, and you can try to comment if you have something that you could improve, or maybe you have a better way to actually exploit this program. There's just let us know, and I will be excited to see your solution. And I would like to actually congratulate for two people that actually sent us right up for Hongwei and Trailblazer. So congratulations very much. So then for other people that haven't been able to solve this challenge, you can look into this video. You can skip into the part that concern you, and try to redo this again. Okay, and all right, that's all. So and then for the second things that I want to know is, for the next week, instead of us War Games create the challenge, we want to invite student from the group to create challenge for us, so we can use challenge and let everybody else solve it, and maybe we can try to solve your question too. So if we will create the announcement later, but we just want you to know that if you have any interesting question that that you made, or maybe you have an idea and you want to make a question, so make it and send it to us, and for from the submission we will choose the best one, the good one from the list, and we will publish it into the wargame group, so everybody else can try, and even us can try, and maybe we can rate your question. If your question is good, we will be happy to try and solve it. So that's all, guys. So thank you very much. So bye and good night.